So, when we talk about AI, you probably think about it writing poetry or creating some wild art. But forget all that for a second. Today, we are diving into a totally new frontier, an AI that's learning to read the secret language of matter itself. This isn't just a small step, it's about revolutionizing discovery at the most fundamental level, the molecule.
Okay, so picture this. You're a scientist. You've just discovered some brand new substance. Now, this could be anything, a potential life-saving drug, a revolutionary new material, or even some unknown pollutant. The very first question you have to answer is actually pretty simple, but it's also incredibly profound. What is this stuff?
So, how do they actually do it? How do you go from a mysterious powder sitting in a vial to a complete 3D model of its atomic structure? This, right here, is one of the most fundamental challenges in all of chemistry. Now, there's a fancy term for this whole process. It's called structure elucidation. Yeah, it's a bit of a mouthful, but all it really means is figuring out a molecule's exact recipe and shape. Which atoms are in it, how they're all connected, and how they're arranged in 3D space. Getting this right is absolutely the critical first step to, well, everything else. For decades, this whole process has been like old-school detective work. Seriously, scientists had a set of tools, sure, but piecing all the clues together was incredibly difficult, it was painfully slow, and it relied so much on expert intuition. And this slide really breaks it down. On the left, you've got the old way of doing things. Super time-consuming, expensive, and you need a human expert to try and match one little clue at a time against databases of stuff we already know. But the ideal solution, over on the right, that's a total game changer. We're talking fast, automated, and, this is the big one, it can identify completely new molecules because it sees the whole picture all at once. For years, that ideal solution on the right was pretty much just a dream. But now, an AI model has come along that's actually turning that dream into a reality. This is the kind of breakthrough scientists have been waiting for. And its name is SpectraLM. Think of it as a new kind of AI chemist designed specifically to crack this age-old problem. Now, the really crucial thing to get here is that SpectraLLM is the first large language model of its kind. It isn't learning from text on the internet. No, it's learning to read incredibly complex scientific data from a technique called spectroscopy. That's basically a way of seeing how molecules respond to light and energy, which gives each one a unique fingerprint. And the amazing part is, SpectraLLM can read a whole bunch of these different fingerprints at the exact same time. So how in the world does it do it? Well, the secret is what's called a multimodal approach. Instead of just looking at one clue, it looks at all the clues simultaneously. And that is what makes it so unbelievably powerful. Let's just walk through how it works. First, you feed it the inputs, all those different spectra or the data fingerprints of the molecule. Then, the AI gets to work, finding hidden patterns and connecting the dots between these different clues in ways a human might totally miss. Next, and this is super cool, it pulls all that data into what the researchers call a shared semantic space. The best way to think about it is like a universal translator, where all these different data languages get turned into one unified understanding. And from that complete picture, it makes its final call, the exact molecular structure. And that's the core idea, right there on the screen. It isn't just crunching data, it's actually reasoning. It's figuring out how one piece of evidence supports or adds to another, uncovering patterns that are, as the researchers say, consistent and complementary. It's like it's solving a puzzle where all the pieces look totally different, but it knows they fit together perfectly. Okay, so the concept is absolutely groundbreaking, but, the big question is always, does it actually work in the real world? Well, the researchers put SpectraLLM through a whole series of really tough tests to find out. And they didn't just test it on one or two little examples. They threw 6 different standardized public datasets at it. This was a serious stress test designed to prove its skills across a huge range of different chemical structures. So what was the verdict? According to the paper, SpectraLLM achieved state-of-the-art performance. It didn't just pass the test, it basically set a whole new standard for what's even possible. This chart really tells the whole story. Look at that. You can see how SpectraLLM just significantly outperforms the older methods that only look at one type of data. We're not talking about a small improvement here. This is a massive leap forward in accuracy and reliability. So, an AI that's really, really good at identifying molecules is great for chemists. But why should the rest of us care? Well, because this breakthrough has the potential to speed up discovery in almost every field of science and industry you can imagine. The potential applications are just huge. I mean, imagine accelerating drug discovery so we can find new medicines faster than ever, or designing brand new sustainable materials from the atom up. For the environment, this means we could quickly identify unknown pollutants in our water or soil. This isn't just an upgrade, it's a whole new toolkit that lets scientists work faster, more accurately, and way more creatively than ever before. For centuries, just figuring out what stuff is made of has been one of science's greatest and slowest challenges. And now we have an AI that can do it with incredible speed and precision. It's like we finally found a universal translator for the language of molecules. So the question this leaves us with is a really big one. Now that we can finally read the blueprint of matter, what incredible things are we going to build next?